and you can go ahead and take it away.
Absolutely. Thank you, Justin. Well, thank you all for being here today. It's a pleasure to meet you all. And, if you have any questions or comments along the way, please post in the chat and I'll do my best to respond to them. I'm Dr. Christopher Mitchell. I'm the CEO and co-founder of a New York City-based startup called Geopipe. We automatically build rich 3D models of the real world. And I am here to tell you a little bit more about what we do today and most relevantly to the hackathon, explain how we might be able to help you with your projects using our tools. We had the honor and pleasure to work with NSIN, then MD5 last year at their Escape from New York hackathon. It was a lot of fun for us to not only provide Geopipe data and models for participants, but to do some coaching and mentoring and see the really clever ideas that people came up with for helping evacuate dense urban areas. So I'm excited to see what you guys come up with this year. So let me share my screen and I will kick this off. All right. So Geopipe is building the authoritative digital twin of the world built by AI. So what that means is we are trying to understand the real world on a global scale. We are making it possible to instantly create analyses, simulations, visualizations, and immersive experiences in the real world. Instead of relying on humans sitting there and mapping what's in the real world, we use AI to automatically understand every object and structure in the real world, from buildings to trees to roads to traffic lights. And we use our AI to label those objects with their properties. As I said, I'm Dr. Christopher Mitchell. I am Geopipe's founder and CEO. I co-founded Geopipe with my longtime friend and colleague, Thomas Dickerson. We both have worked on technical and non-technical projects together for about a decade and a half now. We became fascinated by the problem of parsing the real world and turning it into rich virtual copies for video game applications about 5 years ago now during computer science PhDs at NYU and Brown University, respectively. We're joined on our senior management team by Will Pryor, our VP of Sales and Biz Dev, who is on the call here today. Thank you, Will. And we round out the team with a variety of other talented engineers, interns, marketing professionals, and others who have helped us over the last almost 4 years now build our way to a successful startup with a powerful backend technology powering two customer-facing products. We discovered that reality is incredibly important for several different verticals. We focus on gaming, simulation, architecture, and defense. So in games and simulation, we found that game developers are increasingly being tasked to create huge, immersive, open world sandbox games. But for 1 or 2 square miles of the game world, it can take hundreds of person months to manually build every single object in that world and make it look good enough that a human can walk through that world and say, wow, I recognize this as, say this is 34th Street in Midtown Manhattan here. With Geopipe, you can get a model of that size in less than an hour. The early adopter customers that we worked with, the ones who needed Geopipe's data and models most desperately as we first started the startup, were architects, construction professionals, and engineering professionals. They were spending hours even creating a plain white masked model or adding a few colors and textures to that for a single square block of a city. And because these are humans working at human speed, if they needed an entire neighborhood, that could take hundreds of hours. We made it so that with Geopipe, they can download a model of any size at any level of detail in 30 seconds. And as we look towards the future, we're understanding how we can help professionals trying to train AVs and also trying to train personnel. So autonomous vehicles need to be able to move through virtual cities to be trained far before you endanger real people and real objects in the real world. With Geopipe, we're making it possible to reproduce every curve, every lane, every signal, and every tree in the real world to train autonomous vehicles. We are, at heart, computer scientists and techies, so we get really excited about the cool tech underneath. We solve this problem not by reproducing the issue of humans sitting there and manually labeling the world, but instead teaching computers to do it for us. We take raw sensor data about the world, photos, laser scans, traditional GIS data, and we pass this into our deep machine learning pipeline. We apply techniques to understand first where all the objects are in the world and segment them out, from buildings to trees to roads to sidewalks to rivers. And then for each of those objects, our AI looks at them and figures out, this is a 30-story brick building, here it's setbacks, here's the water tower on the roof, here's the trees outside, here's where the windows and doors are on the facade, here's the 6-foot wide sidewalk and the 4-lane road that abut that building. And we do this on the scale of an entire city. We can reproduce New York City and its 425 square miles in less than a day. We currently cover cities across the US, several in Australia and Europe, and we're constantly expanding our coverage. The first product that we created for our architecture and engineering construction early adopters, and one of the ones that I'd like to demonstrate to you today for your potential use case, is Geopipe Context Snap. This is an in-browser interface built on top of the open source Cesium tool. You might have heard from Cesium some other time this week. And it allows you to actually see our 3D cities directly in a web browser. These aren't, Google Earth or Google Maps or anything like that. These are Geopipe models. And unlike something like Google's data, we actually understand what's in the world, not just how it looks. So not only can you look at these cities, you can click on objects to see exactly what we know about them. So, in the screenshot, I've clicked on a building that happens to be 125 Broad Street in Lower Manhattan. And our system derives physical parameters like how tall that building is and how many floors it has and what color its facade is. But it also includes data that we can get from other sources and combine, like when that building was built, how it was zoned, how much frontage it has on a street, etc. But the real power of this tool is being able to then pull those models out and use them in your own applications. So I'll show you a quick demo of how that tool actually looks right here. This video will play. So when you load up Geopipe Context Snap, you choose the city that you're interested in, and then you can zoom into that city. That bluish box there shows you our coverage for New York City, all 5 boroughs. And then it'll switch to Geopipe's 3D models and load a preview of our 3D models in the web browser. Because it's a web application, it decides to optimize the level of detail to what'll respond quickly in your browser. You can then download those models at up to our very highest level of detail, which includes things like every window cut out of the side of every building. As I zoom in on the same area of Lower Manhattan I was showing you earlier, it will automatically load those higher levels of detail. You can see, for example, the roads, sidewalks, and buildings all there. As I said, if I click on a building, it'll show the information that we know about those buildings. You can also click on trees, roads, water, etc., and it'll show you Geopipes, what we call metadata about those objects. Most of our customers come to download a model, so you can use one of the tools in the top right there and select an area that's relevant to your particular project. So I selected about a 1/3 of a square kilometer area there. 1 second. There we go. And then I can choose, number one, the level of detail that I need for my particular application, all the way from the plain white massings that an architect might want, all the way up to the fully textured, color detailed models that you might want to use if you're creating more of an immersive visualization or interactive application. You can choose the objects that actually go into that model, whether it's the buildings, the terrain, the trees, and then you can also choose a file format that works for your particular application. So we offer things like FBX, OBJ, DAE that can be imported into game engines like Unity or Unreal. You can also use them in programs like Autodesk's tools. You can also download GLTF and GLB, which work really well with 3.js and other in-browser tools if you want to build either something to run in the browser on a computer or even a mobile application for kind of putting the exterior world around whatever you might be doing for your particular project. And then once you've chosen the parameters that you want, you can instantly download that model. Our system generates the real world ahead of time. So once you click on that checkbox to agree and download the model, you get it in a few seconds. I've opened this up in a tool called Autodesk Review, FBX Review, which is one of their tools to just view 3D model files. And you can see we've reproduced buildings with accurate setbacks, glass facades, trees, even some water in a fountain in the middle of that park there. You can, other than just looking at this in a viewer program, then load this into your favorite 3D editor, rendering program, game engine, etc. And if you do have questions as I go, please do feel free to put them in the chat. And I won't spot them right now. I'll look at them at the end. But Will, if you spot anything, feel free to chime in on those questions in the chat. So we've had quite a few architects, engineers, construction professionals, even game developers use this to take models out and use them in their own software. This was a project by a construction company looking at logistics for a big hospital campus in Upper Manhattan, all the way from these kind of high-level multi-block views all the way down to the street where you want to actually be able to see what's going on down on the street. We have customers who've wanted to take new buildings that they're designing and drop them into the city and see exactly how they'll look close up and in the skyline of the city, pulling back and seeing exactly how that's going to look in context. But as we worked on Geopipe, we found that there was a need that crossed every single vertical that we talked to, that these days, it's not enough to just have static models of the world that you download and use. That's necessary for many applications, but for some, you need an entire city. You need the real world in a form that you can explore organically without knowing ahead of time where you're going to go. So for architecture customers, for gaming customers, for defense customers who want to train the warfighter in virtual copies of the real world or do mission planning, for first responders who want to be able to train in virtual environments, we created the Geopipe API and SDK. And they allow us to pull the real world directly into game engines like Unity for things like immersive tours, analyses, visualizations, VR experiences, and much more. With this tool, you can just drop a plugin into a game engine like Unity, and it'll automatically stream 3D models from Geopipe servers as you explore a particular area of the world. I've been using New York City for this demo because I'm a New Yorker born and raised, and New York is very near and dear to my heart, these days more than ever. But we have San Francisco, we have Boston, we have Seattle, we have parts of Melbourne and Sydney, Australia. We are working on all of England, Houston, parts of Philadelphia, you name it. And if there's a city that you do need that we don't have yet, let us know, and it's pretty easy for us to add them. So to give you an idea of what those models actually look like in Unity, this is starting near Washington Square Park and pulling back a little bit. This is notably our second highest level of detail, where to keep things responsive with thousands and thousands of buildings visible at the same time, we use textures for the sides of buildings. And if you're trying to create kind of a really large scale visualization, this is a good technique to make sure that you can load a really large area while still keeping it accurate. And it doesn't have to be just kind of flying around with a camera. You can also hop into a fighter jet and fly through a city, or, go into a car and drive through it, or just put yourself as a human on the street and walk through it. So to show you a bit of a demo of what that process actually looks like, especially if you've dealt with video game engines before and you're curious how you might pull an entire city into something like Unity or like Unreal. This is how you use our Unity plugin. It's freely available on our website. It comes with that same core area near Washington Square Park that we love to show off. But if there's a different area that you need for the sake of your hackathon project, certainly let us know. So I've downloaded the SDK here in the background while I was talking in this video, obviously, from our website, and then popped open Unity. Our SDK is a plugin for Unity, so you just import it like you might any package in Unity. So I can import that. It'll pull in our plugin as well as a few assets to help you get started with little demos. So things like the trees that go with the models, the fighter jet scene that I showed you, a simple kind of flying exploration scene, etc. The configuration for our plugin allows you to specify an API key and a user ID. That way we can give individual users or projects a larger area that they can access. And you can also specify over on the right side there the particular point where you want somebody to start in the world. So I've specified UTM coordinates. Those are geographic coordinates that happen to be in the center of Washington Square Park. And then if I click play here, it'll load up the world and load up multiple levels of detail, one by one, up to the highest level of detail, and you're pretty much set at that point. I can fly through the trees, look along the paths here, go through the neighborhood to the south of the park. And as I said, it'll take care of all the things you might otherwise have to deal with as a developer yourself, worrying about how you manage lots and lots of different models of the world, worrying about all those different levels of detail, worry about populating trees into that world, automatically loading and unloading the necessary models to put around the player as you move through the world. So I'm getting towards the end of this particular demo, and really my demo as a whole. So I also wanted to take a few seconds to talk about some things that have been on my mind as far as how we might be able to help you with your projects, how we might be able to enhance the problem of dense urban environments. We've certainly been thinking hard about this since we've talked to Pat Mahaney, who kind of is one of the foundational people in dense urban environments. You may have heard from him. If you haven't already, I hope you have a chance to speak with him. So we imagine that while the focus of this particular hackathon is on those interiors and how you can understand, parse, visualize, analyze, prepare a first responder or warfighter to deal with a really complicated interior environment, that there's a very important part of that equation that's the exterior world. Those interiors exist inside an exterior. They exist in context in the world somewhere. And in many cases, it's important to plan all the way from the exterior into that structure, or from the interior of that structure out, understanding things like, say, escape routes or views, or how high you actually are above the ground for things like emergency equipment. And we would love to explore with you how you're thinking about working with interior worlds, providing more information and more context to stakeholders, and how we can help you put that into a larger context. I'm more than happy to take any questions. And if you have anything you'd like to speak to us about privately, if you would like to get access to any of our models beyond what we have available on our website, if there's anything in particular that you're pondering for the hackathon, definitely send me an email. My email's on the screen there, Christopher@geopipe.pe. And I'm also, just beyond my capacity as co-founder of Geopipe, one of the mentors of the hackathon. So if you have any questions about kind of working with technology, working with visualization, working with GIS data, working with computer vision and AI, I'd be more than happy to speak to you. I have some office hours set up on Monday. I believe they're at 1 p.m. Eastern time. So feel free to sign up for that. Or if that doesn't fit into your schedule, let me know, and I'd be happy to find something that works. So thank you very much. As I said, happy to take questions.
Sure. So, Christopher, thank you. This is William from Geopipe. Just addressing these questions here. Matthew asked the question, what is the accuracy and how do you check it? All of the data that we create in our Geopipe worlds is ingested from real world GIS data like aerial LiDAR, orthophotos, et cetera. So typically, I think the answer for this is that the accuracy is equivalent to the input accuracy. We're typically sourcing from national sources like the National Geospatial Intelligence Division, things like that. In the real world context, we can talk to some of our customers in, for example, construction, who've given us feedback that we're on sort of the inch scale. So I think for our cities, typically finding that dimensional accuracy, positional accuracy, is on the scale of let's say tens of centimeters or better. Now, there are, of course, things that we generate through machine learning, which are sort of assumptive. But, for example, size, color, number of windows, things like that. But generally speaking, for the simulation, warfighting, gaming applications that we support, we find very good, feedback. Kind of, the image you're seeing on the screen right now from Christopher, has not been cherry picked. It's really just straight out of our data. John asked, is there a model of London? Yeah, we do have the model of London. It's not active on our demo site right now, but feel free to reach out, info@geopipe.com, and we can get you the model. With our AI, when we have the right data sources in hand, we can typically spin up a city overnight. So if you have data, of an area, and I think this is especially important for the intelligence community, something that we can do is take sources of data that are, hard to come by and create these immersive, experiences, immersive landscapes, which, using a minimum of data, just typically some very basic 2D and 3D input.
Thanks for that, Will. Appreciate that. Any other questions?
Just anybody else who's interested in, getting demo access to the platform, Christopher's email is up on the screen, or just info@geopipe.com, geopi.pe. It will get right to us.
What about internal data, or say subterranean data from other maps? I'm assuming that's just another layer that can be ingested, or is it mainly just focused on LiDAR ingestion as part of your pipeline?
Sure, that's a great question. So there's two answers to that. Right now, we do focus on kind of the exterior above ground world. All of our data and our models are accurately geolocated. So number one, if you have a source of that data that's already been modeled in some way, you can usually just drop that right in and it'll end up in the right place, whether that's an interior of a building to fill into one of our exteriors, or subterranean infrastructure that you want to model underneath our streets. The other thing is that depending on the size of the use case, we have quite a bit of expertise on our team and within our system to be able to pull in new sources of data and reproduce those as they should be, within our models directly. So if you had a data set, especially of something like subterranean infrastructure, that you wanted to be able to directly produce as part of our models, that's something we would be happy to explore with you.
Cool, thank you.
Absolutely.
There was one other thing, I guess. What about feed? So say you've got the cityscape built.
Correct.
And then I had a live feed. So for the sake of argument, let's say GPS.
Sure.
Can that be fed in? I mean, can your system therefore hook into external APIs? So you've got the ability to pull this into Unity, on which our platform's based, but
right.
Also if we were to look at this standalone, could we fire data at it? Are there those tools, or is that in the pipeline somewhere?
That's a great question. So if you're talking about something like being able to visualize that GPS data in real time, in something like Unity, that's something we've explored before and actually had a lot of fun with. So I took Mapbox's traffic API and dropped it into Unity with our SDK, so you could actually simulate real-time traffic on the roads of our model. And it was really cool to be able to fly around New York and see, exactly what the traffic looked like at that point in time. We do not do anything to then take that data and feed it back into our model generation process. Can you talk a little bit more about what that particular use case might look like?
Yeah, we did a test with Esri. Basically, we're kind of exploring what interoperability with GIS providers kind of looks like. So first of all, it's brilliant. You're running in Unity and you've got a wrapper available. That's a big win. Fascinated to hear more about your Mapbox SDK fusion. That sounds like it could be an interesting point to have another conversation. But really, just trying to sort of then play back. So when there's lots of different fragmented pieces, but we're interested in seeing what a playback of multiple tracks, say through a building, looks like if you're then projecting it into the world. And if you can kind of create a cross section of a building, then you've got the outside and the inside, and it gives you a great picture of what's happening. Not necessarily real time, but you can see the steps for how you go from post event or data you've already got into something that has the potential for real time.
Sure. Got it. That makes sense. Thank you for that clarification. Yeah, I think based on my experiences working with our tools and other people's tools, that strikes me as something that would work very well in Unity. It does have the ability to let you, if you combine, say, multiple models together, to actually take that slice through them and hide some of the things so you can see what looks like basically a cross section of what's happening in real time. You can run that simulation backwards and forwards as people or vehicles or other objects move through the scene, and then look at that from multiple angles, taking different cross sections. And if there was another tool that you were working with, more of a proprietary or third-party tool, I'd love to talk more offline about how we could integrate our data into that type of viewer.
Sounds great. Thank you very much. Great answer.
Thank you. Great. I guess if nobody else has any questions, then in the interest of giving a little bit of time back to you guys, I hope you'll enjoy the rest of your day and your week. Please do feel free to reach out to us with any questions about Geopipe, about the hackathon as a whole, about the technology that you're building for the hackathon, and especially how we might be able to help you out with data and models. Thanks a lot and take care.
All right, thanks a lot, Christopher. So yeah, everybody, I've recorded this, so if you want to come back and watch it again later, it'll be available online. We'll get it loaded up to YouTube and then links out on Teams and on the DIN. And then obviously if you've got questions that come up over time, reach out to Christopher and see what he can do to help you. So thanks everybody, and have a good one. Bye.
Thanks, Justin. Bye.